Hi everyone, welcome to your video lesson on the different types of frontal boundaries, otherwise known as fronts. So boundaries that separate two different kinds of air masses are known as fronts. You can think of it as the front part of the air mass meeting the front part of another air mass. There's four kinds of fronts. There's cold, warm, stationary, and occluded fronts. We are going to be focusing on the first three, cold, warm, and stationary, although I'm going to also give you some information on occluded. Sometimes you can actually see where two different kinds of air masses are coming together, and other times you can't, but you can see the result, which would be something like this, a severe thunderstorm. Cold fronts are cold air masses that move into an area that is warmer. And cold fronts are shown on a weather map by a blue line with triangles pointing the direction the cold air is moving. So they don't always point the same way, they point the direction that the cold air moves, that is moving to. When a cold front moves into an area, it brings with it a certain kind of weather. And because it's moving into an area that has warm weather, it is always the same kind of weather. It's always the result of the same kind of weather. So cold fronts produce violent periods of heavy rain, very short periods of heavy rain. So that would be like a sudden downpour. Cold fronts usually have very high winds and create severe weather, thunderstorms, hail, that kind of thing. So this is just a diagram showing you that the cold front is moving into an area that has warmer temperatures, and the triangles point to the direction that cold front is moving towards. This is a really cool animation. This shows you the frontal movement. So this is a cold front moving into an area that has warmer air. So cold air is more dense than warm air, and so because of that, it's going to push in and cause the warm air to rise up above it quickly. And that quick rising action of the warm air will create clouds, because the warm air holds more water vapor than cold air does. And as the warm air rises, it's rising in altitude, temperature decreases, so it gets colder as you move up. Well, that warm air can no longer hold that water, and so it falls as rain. And you can see towards the bottom the stratocumulus. That's where that water's falling out of those clouds from the warm air that's risen. So a warm front is the opposite. It's when warm air mass is moving into a place that's colder. And these are shown on a weather map by a red line with little half circles pointing in the direction that the warm air is moving. The weather activity in a warm front usually involves long periods of light rain over a really big area, and that's in contrast to a cold front, which is a small area of very heavy rain for a small amount of time. In a warm front, the clouds are usually really low, and it makes a very foggy or overcast type weather. So here you have warm air moving into an area that has colder air. And because warm air is less dense, it's going to rise up over the cold air. And as it does, again, it's rising up over a long area of the cold air. And that water that was being held in the clouds in the warm air is going to fall out as it rises. And it covers a much larger area than a cold front, because warm air is less dense, so it's going to take longer to move over the cold air compared to cold air moving over warm air. So when we start to compare warm and cold fronts, just kind of wrapping up the last few slides, we want to remember that warm air rises and cold air sinks, that cold fronts move faster than warm fronts and have a rounded shape, and that's because the cold air is more dense, so it behind it. Stationary fronts. So if you think of the word stationary, something that's stationary is something that's not moving. So when you have air that's parallel to a front, the surface position of that front doesn't move. That results in light rain over a large area for several days, which is kind of like a warm front. And on a weather map, it's shown using both the warm and cold front symbols. It's alternating red semicircles and blue, and that's what it would look like. and it doesn't point in the direction anything's moving because it's not moving, it's stopped. So stationary front, that is parallel. So if you have cold air and warm air come together perfectly parallel, they're both gonna stop. An occluded front, and again, this is more for an extension work, when an active cold front overtakes a warm front. So this is when a cold front comes in quickly and completely overtakes a warm front. And it is shown on a weather map with a purple line, and that's because blue and red, so you can see right there, the purple is the combination of the blue and red combined. So an occluded front, so you have the cold air moving in, the cold air is overtaking the warm air mass, and what happens is warm air gets trapped between the two colder air masses and it pushes it up because the cold air masses are more dense, so it's going to push the warm air up above it. And so it's when two cold air masses meet and they push the warm air, which means that's why it's called overtaking, because it pushes it out of the way. It overtakes the space. And again, when the warm air rises, its ability to hold moisture goes down, and so it drops out as rain because it can't hold it anymore. So here's just some practice to locate the 4 types of fronts on this weather map. Can you find the cold front? There's one. Are there any more? There's another. And one more. How about the warm fronts? Just one of those and stationary. And one of those. And there's the occluded hiding up in the top left in the northwestern United States. So let's be a weather forecaster. You're planning to travel to Alabama in 2 days. Alabama is the state shown with the star. The high temperature there for today is 68 degrees Fahrenheit. Use the map to help you predict whether the temperature in Alabama will increase, decrease, or stay the same. Explain why you think so. So take a minute to look around Alabama and see what kinds of fronts are around there that could affect the weather in Alabama right now. What do you see that is getting closer to Alabama? Which kind of front? There you go. It's a cold front. So cold air is moving into Alabama. Temperatures will most likely be cooler behind the front. This part is just a review on your types of clouds. So you guys spent some time doing card layouts on the types of clouds. I just wanted to include this as a quick overview for you. So cirrus clouds are the clouds that look like little feathers. They are high up and they are made of ice crystals. Cirrus clouds don't mean unstable weather, but if there's a lot of them, it might mean that a storm is coming. Stratus clouds are the low-level clouds. Those are the clouds that are, when you look out and all the sky is gray, those are stratus clouds. And those are related to warm fronts. Cumulus clouds are low-level. Those are like the cotton ball clouds. And they don't usually have severe weather associated with them. You'll more than likely see them with blue skies. Those are the fun clouds that you can make shapes out of. But when they mix with stratus clouds, they can show up in cold fronts and they can produce heavy amounts of. So here's some cirrus clouds. They're really high up, wispy clouds at the very top of the picture. Here's stratus clouds, very low clouds, and cumulus clouds.